Okay, hello everyone. Thank you for joining us today. Apologies about the delay, small technical difficulty. My name is Kara Gordon. I'm the Partnership and Communications Coordinator for ECU's Center for Sustainable Energy and Environmental Engineering. I'd like to welcome everyone today to our webinar on mainstreaming green chemistry in metal finishing operations, finding the indicators. Our mission at the center is to promote renewable energy technology and natural resource conservation through scholarly and applied research, an effort to enhance industry awareness and best serve North Carolina communities. With research funding through the EPA's pollution prevention program, and source reduction assistance programs, our center students, faculty, and affiliates provide valuable resources to businesses and industries across North Carolina. We offer energy, P2, and lean assessments and training largely to North Carolina automotive, chemical, fabrication, and food and beverage manufacturers. After conducting a facility assessment, the center additionally provides technical feedback and various business analyses. We also facilitate certification workshops like Lean Six Sigma for sustainable and green manufacturing. This Wednesday, the center will host a free online training course, the iOS 5001 or 50001, however you say it, an overview of energy management systems from 8:30 to 4 p.m. Eastern Standard Time. This course is designed to provide a general overview of concepts, requirements, and benefits of using an energy management system based on the iOS 5001, 50001 standard. This is an excellent opportunity to earn continuing education units, absolutely free with support from the EPA's pollution prevention program. The registration link will be provided in our follow-up email. So before I introduce today's speaker, just a little housekeeping. We're recording today's event. Access to the event will be provided in the email concluding today's webinar. We encourage you to interact with our speaker. We will take questions at the conclusion of the presentation, or you can drop your questions in the chat box at any time, and I will ask our speaker after his presentation. In the follow-up email, I'll also provide a link for feedback. If you could just take a moment to tell us how we can improve our future events. And then finally, the email will also contain a link for donating to the center. Or you can simply go to give.ecu.edu/CSE3 at any time. We gratefully appreciate any help and contribution as they help us to support student research activities and community engagement. So our speaker today is Miguel Rodas, graduating from California State University in Los Angeles with a BS in Natural Sciences with a major in chemistry. He has been with the City of Los Angeles' source control program for 18 years. He performs inspections and sampling of facilities subject to federal regulation as part of his duties as an environmental compliance inspector. Miguel is part of the P2 and green chemistry team at the LA Sanitation and Environment, in which, along with other team members, coordinate the pilot project in metal finishers to collect data for the creation of the P2 and GC checklist. Miguel has been recognized by the California Water Environment Association for his proactive role and contribution to promote source reduction and P2 practices. His work includes researching best management practices for metal finishers, assisting training staff in LA sanitation, and educating industrial users with issues related to regulatory compliance. Prior to joining the City of LA, Miguel gained industry experience working in the lab for an electroplating shop and in textile and the dye house industry. In his spare time, he enjoys reading theological and technical scientific papers, playing guitar, and bicycling. So thank you, Miguel, for your time and expertise today. I will turn everything over to you, and I will get your presentation loaded up.
All right. Yes. Good morning, everyone. And I'm sorry. Thank you very much to the East Carolina University, Dr. Salam and Kara, and the engineering department for the opportunity to make this presentation. And it's about advancing pollution prevention and green chemistry in metal finishing operations. Next, please. As Kara mentioned, um, I have been doing performing inspections of metal finishers and other type of industry in the city of Los Angeles for the last 18 years. Next, um, what I have prepared for you is first I will give a very broad uh, brief introduction of what is the industry and city of Los Angeles, just to set background of this presentation. And then next, I will move into pollution prevention and the green chemistry checklist that we have developed. And then the part of the preparing the checklist, I collected some data and I will explain the findings and the application of that data. And lastly, we'll move into what is the strategy that we're taking in the city of Los Angeles to mainstream green chemistry. Next. Go ahead, next. Well, industry, we divide practically the all type of industry in city of Los Angeles in three main groups. Is the fog, which is the fats, oil, and grease. Those are the restaurants. And then we have the smaller shops, which are named as local industrial users. And then we have the significant industrial users. In all, we have about 26,000 facilities that are connected to the city sewer line to discharge industrial wastewater. The most significant group of industries uh, connecting to the city sewer line is the categorical significant industry users. Of those, we have 112 categorical significant industrial users, and we have 61 non-categorical industrial significant industrial users. Next, please. To address the problem with industry and also to reach out industry, City of Los Angeles created a LA industry program, which is led by Jennifer Kong. And also this is the initiative of our division managers, Mr. Michael Simpson. And the objective was to reach out to industry. Several champions groups were created to reach out the different type of industry and city of Los Angeles, having in mind that the mission of the Industrial Waste Management Division is to protect the public health and safety, the treatment plants, and the environment by implementing the effective and efficient source control while enhancing the relationship with the industry and also enhancing and bringing new information on sustainability and circularity. It is one of the main objectives of City of Los Angeles to help industry to cope mainly with regulatory the regulatory responsibility and also in turn to promote the economic development and the continuity of industry and city of Los Angeles. Next, please. And these are some of the champions groups that were created within the city of Los Angeles to reach out this specific type of industry. And we have the textile industry, we have the car wash, we have the cannabis, which is recently a new group. Then we have micro brewery, we have the industrial laundries, we have the groundwater, and of course today I will speaking, and I am the champion representing the metal finishing group. And as you can see, metal finishing, for those of you who are not familiar what is metal finishing, we see it in our kitchen with the Chinese appliances that we have. Some of all of them has been gone or undergone some sort of metal finishing, so they can look nice and shiny. Next, please. So what are we doing exactly to reach out the metal finishing sector? First of all, our objective is that to bolster our relationship with the industrial sectors, to remove barriers. In the past, we have experienced, at least when I started with City of Los Angeles, we experienced a sense of adversarial relationship. So breaking those type of barriers, it was very important for us, so they can, industrial users can trust us. And also we bring new updated regulations, and we inform them, we educate them, we promote compliance and sustainability and green chemistry through webinars, workshops, printed materials, and of course recognition. And that is exactly the ultimate goal of the green certification that we're working toward. That will be the recognition given to them for their efforts already doing in promoting and also implementing pollution prevention and green chemistry. Next, please. Uh, this is exactly the inventory of metal finishers that we have in City of Los Angeles. We have a total of 89. We have lost some of these industrial users through the years. When I started, we had more than 100. And so far, as of today, we have 89 facilities. And for you that are not familiar with the federal regulations, we have two main groups of metal finishers. Those that are subject to the federal category of what is called 40 CFR 413 and 40 CFR 433. These are the biggest group. And then we have other facilities that are subject to a combination of both 413 and 433, and also 433 and 464, which is the casting, metal casting, combined with metal molding and metal finishing. And then we have 471, which are facilities also doing metal forming. That one we have only one facility. So this is the group of facilities that represent the major threat, I would say, to the pretreatment program, since the discharges that they do have the chances of causing interference to the city sewer line, and also to cause pass through the treatment plants due to the nature of chemicals that they use in their operations. Next, please. So what is metal finishing? For those that are not familiar with metal finishing, is like when you put a coat of paint in your home, that's exactly what you're doing, putting a fresh coat of paint so it can look better, and also to protect the wall. So in the same manner, metal finishing is a comprehensive term used to describe the process of placing some type of metal coating on the surface of another metallic part, typically referred to as a substrate. And in the metal finishing industry, we find different type of substrates. We have aluminum and different type of steels. Next, please. And so why is it metal finishing important? Well, we know the effect of corrosion. And the effect of corrosion is the deterioration of infrastructure materials, and the also the breakdown of many important structures that, such as bridges. Next, please. And so, in order to protect those very important infrastructures, to protect against corrosion, metal finishing is a very important way of providing that protection. And not only does a protection and resistance, but also bring an increased functional to the different type of parts, such as friction, wear, conductivity, hardness, and other uh, extreme conditions. Parts sometimes are exposed to marine environments, for example, and so corrosion protection is very important. And lastly, also we see that this in the jewelry industry. Some metals are coated with gold or silver. So that's to increase or enhance these parts through decorative or increase their appearances. Next, please. Again, for those that are not really familiar with metal finishing operation, and I'm for this presentation, I'm assuming that some of you are somehow familiar with metal finishing operation, but in case you're not, this is exactly the three main operations that when you get into a plating shop, a metal finishing facility, you will see three type of operations. And the first one is the surface preparation, perhaps the most important part in the entire process, because it comprises the cleaning of the surface. So again, when we are going to paint or apply a coat of paint into a wall, the first thing we need to do is clean the wall. So this is exactly the same function in metal finishing. Surface preparation can be done in a physical way by electropolishing, buffings, and other physical means, and also chemical by removing oxides and other impurities through the use of inorganic acids. The next process is the actual finishing. And here we have 6 core operations that if a facility is doing one of these 6 operations, will be subject to the federal regulations under 433. Next, please. And the 6 core operations are electroplating, electroless plating, anodizing, chemical etching and milling, coding, and the manufacturing of printed circuit boards. And the last, the process that is involved in the entire finishing of parts is the post finishing, which means that after applying a electroplating coat, the parts can be sealed with any other material such as nickel acetate and also chromates. That is basically what you will see in a facility doing metal finishing operations. Next, please. And so here, where are the opportunities for pollution prevention is exactly in the 3 steps. And this is a very concise, summarized type of way of putting everything, but the pollution prevention opportunities and green chemistry, well, we're going to find them right in these 3 steps. Next, please. When I was asked to create a P2 checklist, I used the entire inventory, 89 facilities, to come up with a checklist that will serve to evaluate a facility and ultimately to grant a green certification. I my work built up on a already a work done by our senior engineer who is now retired. He put the fundamentals of a checklist already, and we grant some pollution prevention practices already to industrial users, and those are already written in the permits that we grant to industrial users. However, what I did was to include some more that are greener or and are greener in the way that they have a great impact, positive great impact in the overall uh, operations of the facility. And the compartment of this checklist are water conservation, where we see two sections, one that focus on water controls and the other one that focus on efficiency of the water use. And then the next compartment is the elimination of chemicals of concern. And here we have three sections: process substitution, material substitution, and product change. And lastly, the last compartment is mainly on operations and maintenance. And here we have four sections. I will explain the four sections in the next slide. And the four sections in operation and maintenance are, next please. First, again, click. We have the operations and maintenance. Next, we have the installation of pollution prevention and equipment and systems. Next, we have the on-site reuse processes. And next, we have the off-site recycling and reclamation. All these processes are part of or the pollution practices within these subsections are included in the checklist for the evaluation of a industrial user or a metal finishing in this case for uh, its evaluation of what are they doing in terms of pollution prevention and in green chemistry. Next, please. And the data that I found, I took the entire inventory, 89 facilities, and then I came up with more or less what the entire inventory is doing in terms of water conservation. Remember, this is the first compartment of the checklist. And the most pollution prevention practices used by metal finishers is the use of a spray rinse. And then we have next, we have the static rinse and flow restrictors. See, those are different type of water conservation. One is purely flow controls, mechanicals, and the other one is more water efficiency. However, static rinses, cascade rinses, and overtime rinse and spray rinse are not the most efficient water conservation methods. And next, we have the counter current rinse, which is the most pollution prevention practices that brings the most significant impact in water conservation. And I put a green mark on this counter current rinse that is not showing up when you, maybe when you click, it will show up that, yes, there we go. This, I put that to signify exactly that the counter current rinse is the most significant pollution prevention practices with the greater impact on water conservation and water efficiency. However, out of an inventory of 89 facilities, only 20 of them are implementing counter current rinse. Next, please, the next slide. And here we have the slide on, I put this together, materials and process substitution. The most pollution prevention practices related to these materials and process substitution, it is through the alkaline degreasing. Remember, the most important step in metal finishing is the cleaning of the surface. And many industrial users use organic solvents to perform the cleaning, to perform that surface preparation. However, in City of Los Angeles, due to the work that we have been doing, more and more of them are using alkaline degreasing. I will talk a little more later on the type of other materials available for cleaning that we still need to promote. Uh, the second one most significant over here is the use of trivalent chemistries. We have only 3 facilities that show us that we need to work on promoting more the elimination of hexavalent chrome, and also so that we can persuade industry users on to shift the chemistry from hexavalent to trivalent chrome, and also for the replace of cyanide chemistries. We have only 4 facilities that have replaced cyanide for non-cyanide chemistries. Remember, cyanide is also a major chemical that represent health and safety hazards, especially for workers. And the next significant uh, process or pollution prevention is the drag out reduction. This one, in my opinion, is easy to implement. However, represents a little movements of the layout of the tanks. However, the drag out reduction represent that the prevention of loss of precious chemicals that are part of a process plating bath. And however, only 15 facilities have managed to do drag out reduction. Um, Next, please. And here in operation and maintenance, this is very interesting because uh, the operation and maintenance, remember in the compartments, one was blue, one was green, and the other one was brown. So the brown represent the empirical operations. Industrial users or metal finishers that are doing operating in a very empirical way. No technology is involved. Many industry users, many metal finishers opened up their operations or open up their companies just based on copying the dynamics from another facility. They thought that it would be just immersing parts on a chemical bath or a plating bath and then rinsing and then rinse again and then it's done. It is in fact that. However, metal finishing or the science of metal finishing, it involves the intersection of 2 major, very important subject matter, which is chemistry and physics. Physical chemistry. I had a hard time when I took physical chemistry. Now is my favorite subject matter. However, many metal finishers are operating with no clue of what is physics and what is chemistry. And as you can see over here in this chart, many of them, they do employee training, but there's no training in chemistry and there's no training in physics. The training is how to clean up the floor after the spills, and also housekeeping. The housekeeping is so poor that as soon as you get into a metal finishing facility, you will see the housekeeping is terrible. And many of them are subject to the what we call the fire department. In California, the Department Toxic of Substances Control run a program that is managed by the local fire departments, and they enforce the health and safety aspects of the emergency type of situation when dealing with chemicals that are dangerous. And although our inventory, we have 72, 75 facilities, almost all of them are doing this type of operation. However, it is ironic that almost always the fire department always find deficiencies regarding to housekeeping and employee training on this aspect of operations. One pollution prevention practice that I want to highlight is the TOMP, TOMP, which is the Toxic Organic Management Plan. And this is a proactive action from our part, City of Los Angeles. And we help industry users on identify all the organic solvents that they're using. And we ask them to fill out a form of what are they doing with these organic solvents, how they manage these organic solvents. And if the data of 3 years shows that the concentration of organic solvent is below a reasonable concentration value that we have, then we grant them a waiver. And the waiver is comprises of an exemption for monitoring organic solvents. We in the City of Los Angeles does the monitoring of organic solvents. Now, the catch is that if within the 3 years, the concentration of organic solvents of any, and we have a whole list of more than 100 organic solvents that are subject to this regulation of 40 CFR 433 or 413, and if any of these organic solvents or the sum of the organic solvents become higher than the established effluent limitation, then the waiver is canceled and they will have to go and again start monitoring or taking samples for organic solvents. The SB14 is only over here, Tom. Only 24 facilities are taking advantage of this toxic organic management plan, which means we have to do more work on convincing industry users on jumping on this waiver, which is very useful. It reduces the monitoring, the sampling, and the cost of analyzing for organic solvents. And the next one is SB 14. This is strictly California and it doesn't apply to everybody, but SB 14 mainly is for those that generate hazardous waste to a threshold of certain kilograms per month. And we have in our inventory several of those. 15 of them are subject to the SB 14 and they need to report to the Department of Toxic Substances Control on this. And we keep an eye on them on this. And as you can see, equipment modernization is very, very few, only 10 facilities. And facilities that are doing ISO, this is a quality control mechanism, ISO, we have only ISO 14, we have only 3 facilities. So this means the amount of work that we need to do on promoting pollution prevention. Next, please. And here, what is exactly green chemistry? Now we're jumping into what is green chemistry. Green chemistry is an innovative way to create products and processes that reduces the generation of hazardous substances. This is a very generic, very general definition of green chemistry. Next. In City of Los Angeles, we have an office for a Los Angeles green business, and also in California, we have the California Green Business Network. Right now, currently, we are working with them in with this checklist that eventually will become approved by the California Green Business Network, and so we can grant this certification to metal finishers after a exhaustive evaluation of what are they doing in their operations. And again, the checklist will go through the checklist on what are they doing in terms of water conservation, the green compartment, which is process, material substitution, and in operations and maintenance. Next, please. Green chemistry is the utilization of a set of principles that reduces or eliminates the use or generation of hazardous substances in the design, manufacture, and application of chemical products. This definition came from Paul Anastas. I'm sure all of you may know who Paul Anastas is. He's considered the father of green chemistry. Next, please. But again, is very, very generic, very general, and intended for the chemists at the lab level to be implemented. And he came up also with the 12 principles, which are those there. I will focus for this presentation on the prevention principle that I have applied that definition of what is prevention in metal finishing, because the 12 principles are nothing else but ethical principles to be followed for chemists before they do a play around with atoms, molecules, and all that to create new substances. So they need to take into consideration these 12 principles for creating cleaner, safer chemicals. Next, please. And how are we going to measure the degree and measure of greenness? Next click, please. I have taken into account the perspective given to us by the Green Chemistry and Commerce Council. And I, in during my readings and research for this project, I found this article written by Anne Blake, and it's measuring progress toward green chemistry, which gave me the idea for this presentation and the strategy that we're taking in City of Los Angeles. Anne Blake proposes that the metrics may include or are at the molecular, the process level. And here again, this one applies to chemists at the lab level, and also products and materials. Again, chemists and chemical manufacturers that they do design and do the mass production of chemical products, and also at the firm and sector level. And here, that at the sector level, I saw the opportunity to include the metal finishing at this sector, industrial sector level, and then also metrics at the societal level. Next click, please. Our strategy is to follow, or the metrics that we are proposing are related to the raw materials used in metal finishing operations, the chemicals that are considered of concern that are in metal finishing operation, also the processes that are involved in metal finishing, and the manufacturing practices. Remember, in metal finishing, there is no manufacturing, it's finishing. They already receive pre-manufactured, prefabricated metal parts. So what they do is just the finishing of those. And then we're going to focus on also on operations and maintenance. And here is what we find again, the three compartments of that checklist. So while the GC3 is calling us to do the mainstream, GC is to look at broader definition. We are looking of focusing more at the sector level, at the metal finishing sector level, and the proposed metrics that are going to be in the checklist are there. For now, on this presentation, I will explain a qualitative metrics. Next, please. And so we need to remember that under this perspective, not all pollution prevention is green chemistry. However, green chemistry is pollution prevention at the molecular level. That's a very important concept that we need to grab, because we cannot look at every pollution prevention as green chemistry. It's not. However, the new products, the new chemicals that are being created now, hopefully are at the molecular level, are pollution prevention at the molecular level. Next, please. So where do we find these green indicators? Again, here we have the three compartments again, the water conservation, process and material substitution, and then we have the operations and maintenance. And the indicators are going to be found in between the intersection of these three main compartments. If we look at the metal finishing operation as a one unit, all of them are there is an interchange of materials in between these three main compartments. And so the green indicators will be found in within these intersections. Next, please. And so the three compartments again are the green chemistry, process substitution, material substitution, product change. The next is the water conservation, which is range efficiency, water control technology. And next, we have the operations and maintenance, mainly on pre-treatment system technology, the reuse and recovery of materials within the operations of metal finishing, the environmental management systems implemented in the overall operation, housekeeping and training, again, very important. And I have put this one in this list as very important, the management of the organics in the overall operations of metal finishing operation. So while the benign by design model of green chemistries was praising, the metal finishing sector is still lacking using and still relying on all brown chemicals such as nitric acid, sulfuric acid, hydrochloric acid, phosphoric acid, fluoroboric acid, chromic acid. All these inorganic acids are found in this green compartment that I see there. That I developed another version of this PowerPoint, which I put it in red, but this one is not the most updated PowerPoint. However, I put red with green, which means that in essence, metal finishers operations are filled with many inorganic, nasty, toxic acids that they need to be replaced sooner or later. In terms of green chemistry, we're already behind, in my opinion, 20, 25 or 30 years ago. And this industrial sector is still lacking in using these brown chemicals. Remember, green chemistry is no different than the conventional chemistry. Green chemistry is the same chemistry, only guided by principles. Next, please. And so the this formula over here, how are we going to evaluate the degree of greenness in a metal finishing operation? And this formula comes from the former senior engineer who created the fundamentals of all these pollution prevention checklists. And he was the one who provided me with this formula. He said, okay, so he said, after several conversations with him, he said, so here is what you have. You want to measure greenness. And how are we going to measure greenness? Greenness will be a function of what type of green chemistry we can find already in metal finishing operation. And in addition, the extra pollution prevention practices that make a significant impact in the overall operation of metal finishing. And what kind of impact are we talking about? Now we're talking about emissions that affect the surrounding communities, and also the impacts on the surroundings, the local communities, on spills and malpractices that are related also with operation and maintenance, and also the huge water consumption by some of them. Remember, water is a precious commodity, and that we need to promote more water uh, conservation and less water consumption. Let's next, please. And so over here in go back, please. I want to go back again one last. Here the arrows in red arrows. It means that uh, the pollution practices that make great impact on metal finishing are around again of the three compartments, and any changes that we make in one of these compartments will make a effect on the other three compartments. For example, less water consumption, so we will have less water to be treated, and so therefore the regulatory compliance will be easier. Next, please. Now here is a sample scorecard that I did on 3 facilities. I put facility A, B, and C, and we evaluated product change, product substitution, material substitution, water conservation, and operation and maintenance. Very simple a color code scorecard, which is the qualitative assessment that I was telling you, a simple addition of adding all what I found in these 3 facilities in terms of pollution prevention. And as you can see, the one with 15 has a mixed color of brownish, which is very little, and then blue, and then green. So under this strategy, we can identify other pollution prevention practices that we may suggest to industrial users so they can make the next step and become fully green. There's still going to be some kind of brown because there are operations that are not. Remember, pollution prevention, not everything is green chemistry. So, but facility A, for example, has remained brown uh, all the time. Water consumption is too high and there are no material substitution. They still rely on organic solvents to cleaning parts and all that. So this give you an idea of the color qualitative method on how to assess a facility. Now there are, under the formula that I gave you, there are degrees of greenness and within each compartment. And here we can develop a formula that will require more mathematical inputs in making a numerical assessment. Next, please. And now green two practices. What are the green two practices that I want to highlight over here? And I have considered those green because they are already green. The non-cyanide chemistries. This is actually if a pollution prevention practices is less impactful on health and safety of workers and the environment is cyanide, then it is considered green. The trivalent chrome, for example, in California, the California Air Resources Board is already providing incentives, funds, economic incentives for metal finishers to deface or get rid of hex chrome and instead to adopt and bring in trivalent chemistry. EPA already, with the Green Chemistry Challenge Award, has already validated this as a green activity, as a green source of reduction. The drag out reduction also, it is a very significant pollution prevention practices that helps in recovering precious constituents of electroplating bath. And zinc nickel instead of cadmium. Cadmium under the European regulation of Rodas or restriction of substances, restriction of hazardous substances. Cadmium, chromium, lead are not allowed in any of the products that are finished by metal finishers. And this alternative of zinc and nickel instead of cadmium can be considered green. Next click, please. And then we have material substitution, also the alkaline cleaning, the one I talk about, and tin only instead of lead. The alkaline cleaning is the toxic reuse inventory release 6 green codes. And one of them is the alternatives of replacing the surface cleaning of metal parts using organic solvents. So if alkaline cleaning replace that organic using organic solvents, then it is a green activity. And tin only instead of lead, again, lead is a very one of the restricted of hazardous substances, and many printed circuit board manufacturers are already jumping. At least one in the city of Los Angeles. We have two already replacing lead, tin instead of lead. Next click. So the new processes and emerging technologies in process substitutions are in the powder coating, and that is called the zirconization, and also the nickel tungsten silicon carbide plating. We have not yet in city of Los Angeles any nickel tungsten silicon carbide plating yet. However, I have seen read literature that already the Defense Department is already trying this alternative. Next, please. In the material substitution, we have the modified alcohols. Uh, Remember, dirtiness, the very important part or step in cleaning up operations is the removal of dirtiness. And believe it or not, but even dirtiness has polarity. So there are dirtiness that is polar and non-polar, and the alcohols, the modified alcohol, can be both, and are being designed to clean both type of dirtiness. I don't have any specific example for you on modified alcohols, but this is also a new trend. And also they just as last week, I found that one anodizer in our inventory, he reported to me no longer doing hexavalent chromates. Instead, he's using hexafluorocirconic acid. So that would be a green alternative for hexchrome also. Next, please. I'm not sure if I have time for the next slide, but it's the very light, the very last next slide. Do I have time, Kara?
Yeah, you're fine.
Okay. Uh, so basically, I think all of you have seen this triangle, and is the hierarchical a triangle of waste management. What you see over here is my interpretation of the same triangle, and at the very top, a facility, if they want this certification, the green certification be granted to them, they need to do a lot of process substitution, material substitution, reduction of elimination of chemical of concern at the very top, and then implement pollution prevention practices that reduces and increases the recovery of the drag out. That is the recovery of precious constituents of electroplating bath, and also more water conservation techniques and controls to consume less water, to produce less water to be treated. And that comes into the installation of pollution prevention techniques and systems to efficiently treat the wastewater, comply with the effluent limitations, and lastly, at the very bottom, is the less water they consume, the less waste they consume, the less solid waste, solid or semi-solid, that they need to manifest offsite their facilities. That's the great idea of behind this strategy on becoming green. Remember, chemists has been given the opportunity to transform the landscape of all industrial sectors. Yet we don't see that transformation. So we need to take an alternate path on mainstreaming green chemistry. And this is the strategy that we are taking in city of Los Angeles by already recognizing the efforts of many metal finishers that are making big investments. One of my facilities, the one I go and inspect, they invested more than $100,000 in installing a trivalent line. So we need to recognize those investments made by these facilities too, and we need to acknowledge that that is a green step toward better operations. Thank you very much for your attention, and if anybody has questions, I will be glad to answer.
Thank you so much, Miguel. Let me end his presentation and get back to my presentation. Excuse me a second while I shift over. Okay, so at this point, if anyone has any questions, you can drop them in the chat. Let's see here.
And yeah, and perhaps I am able, I'm open to, if they have questions, I can reply back either to you and you reply back to them if they have questions. If not,
So
then
if
yes,
you
go
think
ahead.
of any questions later on in the day or need to
Yes.
contact Miguel, his contact information is at the end of his presentation, which will be included in the follow-up email today. So just be on the look for that. Or you can contact me at sustainabilitycenter@ecu.edu with any questions, and I can facilitate that to Miguel. Otherwise, if there are no questions, then we will go ahead and close out today. We thank you for joining us very much. And our next webinar will be on April 4th from 11 to noon Eastern Standard Time on energy cost and demands in wastewater treatment. Let me just double check, make sure I'm not missing any questions. Okay. We've got a from Jill, excuse me. This was very interesting. Thank you. We're getting some thank yous coming in.
Okay, thank you very much.
Fantastic
Yes.
presentation. Yes, that was very interesting. It's been a long time since I have done any kind of chemistry, so that was kind of bringing back some terms from a long time ago.
Okay.
Anyways,
That's good to hear.
Well, again, thank you so much, everyone, for joining us. And we will see you at our next webinar event on April 4th.
All right. Thank you very much again.
Miguel, if you would like to hang back until everybody leaves, I just need to tell you one more thing. So let me stop the recording.